Zigbee is a very popular protocol. It is supported by the Zigbee Alliance. And it uses the IEEE 802.15.4 protocol, but it adds on higher layer protocols, and it supports low power radio communications, where the physical layer, as in terms of the radio frequency modem, and the MAC, medium access control functions, these are specified by the 802.15.4 protocol. However, Zigbee provides the upper layers, the application layer and the network layer. These two on the top are what the Zigbee protocol add on. And once again, the Zigbee protocol is made by the Zigbee Alliance. And that's on top right here. So it uses the medium access control, which is multiple users sharing the network, that coordination function, as well as the physical modem, which connects to the radio frequency channel down there, is used, of course, in Zigbee. Zigbee works well in isolated network environments. And typical topologies include star, mesh, cluster tree, or hybrid networks. The star network is a basic and most common topology. The mesh and P2P can provide high reliability through multiple routes between nodes. The cluster tree network is a combination of a star and P2P topologies. Where do these come from? These are of course available because the IEEE 802.15.4 protocol enables these functionalities. 6LoWPAN. This is IPv6 over low power wireless personal area network. This is an IETF, Internet Engineering Task Force standard that uses the 802.15.4 PAN technology. It supports IPv6 packets over wireless PANs that are based on 802.15.4. IPv6 packets. What advantages do these packets provide? This enables IPv6 IoT wireless network support. So, if a device is already IPv6 protocol based, then 6LoWPAN becomes a very attractive option. Low power design aspect included, which is very good for low power consumption, meaning that the IoT device battery can go on for a long time. The true advantages are that you can directly connect to an IPv6 internet. What does that mean? What are the advantages of that? Number one, you can use IPv6 security, the high-level protection security of that, such as IP security, IPsec, IP-based encapsulation, authentication, access control, firewall protocols, and others. IPv6 naming, addressing, translation, lookup, discovery, these type of functions are all included. 6LoWPAN characteristics include small packet size that supports 16-bit short or IEEE 64-bit extended MAC addresses, and low data rates of 20, 40, 250 kilobits per second. Star or mesh topology using full function devices and reduced function devices of the IEEE 802.15.4 protocol. In addition, good for low power battery operated nodes. And this low power is in its name, 6LoWPAN. The low stands for low power. And these devices are relatively low cost, which is very attractive in their deployment and product purchasing. Then comes header compression, which is critical in WPAN techniques. So, looking at 6LoWPAN, IPv6, and packet sizes. Well, the IPv6 has a minimum packet size of 1,280 octets. The IEEE 802.15.4 has a maximum transfer unit, which means that the maximum size of an IP packet that can be inserted into it is limited to 127 octets, 127 bytes. So evidently there is a huge mismatch of more than 1/10 of a degree of a mismatch here. The IPv6 header has a big header, which is mainly because it uses IPv6 addresses, which are 128 bits each for the source and destination. And that makes the IPv6 header very large, 40 octets, 40 bytes. So And that is just the minimum header. The IPv6 header can have many additional options added to it, such that it has additional features that are provided. And some of those features we already talked about, as in terms of IP security or other features that are added on. Now, so that is why we need to compress the IP address and other fields. So if you can derive some of the field characteristics from other fields in the header, then the ones that you can derive, you want to compress them, which means that you do not send them, or maybe send them just once at the beginning, save them, and then for the following packets that have the same repeated fields in the header, you just do not send them. You have a compressed format that you skip sending them because you already sent them once. And these type of techniques are what we mean by header compression. So compress the prefix of the link local address. So completely omit the 128-bit IPv6 address if it can be provided from the link layer address. So if you already know the link local address, then, and you know what it maps to as in terms of IPv6 address, then you don't need to send the IPv6 address. When you send the link layer address, automatically at the receiving end, then they will match it and reconstruct the entire complete IPv6 packet. Compress common headers such as TCP, UDP, and ICMP. These are the references that I used, and I recommend them to you. Thank you.